This is continuation of our review session for exam 3, Chem 112. I'll begin with balancing of electrochemical reaction. So let me write down a chemical reaction and explain to you how to balance it. Cr2O7 2 minus plus CH3OH giving HCO2H plus Cr3 plus. So we need to balance this reaction. Let me write down different steps involved in the balancing. So step number 1, balance elements other than hydrogen and oxygen. So any element, you need to balance elements other than hydrogen and oxygen. Now before that, you need to split that into half reactions. So let's write down that as second. Split in half reactions based on similarity. So we are going to split this reaction into two half reactions, then balance elements other than hydrogen and oxygen. So let's first do this splitting part of the reaction. This is the total reaction. Here I have chromium, here I have chromium. So my half cell or half of the reaction would be, we call it this is called half cell reaction. O7 2 minus on the left hand side. On the right hand side you have Cr3 plus. The other half cell reaction would have CH3OH on the left side and HCO2H on the right side. So let me write down the other one. We can write down this on this side. CH3OH, that giving you HCO2H. I think I need more space here. Let's have a line here. Okay, this is how I split my reaction into two half reactions on the basis of similarity. Like chromium I have on both compounds. This is Cr2O7, this is Cr. And of course the rest of these compounds are making the other half reaction. Now we are going to balance elements other than hydrogen and oxygen. Now this doesn't have hydrogen, but it has 7 oxygen. But first we need to balance Cr. I have 1 Cr on the right side, 2 Cr on the left side. So I need to balance it by having 2 in front of the Cr. So that is going to balance Cr. So next you need to do balance oxygen by adding H plus. So balance oxygen by adding H2O. Okay. So balance oxygen by adding H2O. So in this case I have 7 oxygen, so I'd be balancing it by adding 7 H2O. I'm working on this half reaction now. Fourth step, balance hydrogen by adding H plus. When you added H2O, now obviously you have some hydrogens there. Now I have here 14 hydrogen. There is no hydrogen on that side. So I need to add 14 H plus on that side. So once you are done with balancing hydrogen, step 5, you need to account for charges. Balance charge by adding electron. Each electron will be -1. So let's account for this, what charges we have. 14H plus, that's plus 14. Cr2O7 2 minus is -2. So on the left hand side I have plus 12. On this side I have 2 times the C plus on each chromium. So it's plus 6. And water is 0, it's neutral. So I have plus 12 on this side, on the left hand side, plus 6 on the right side. I'm only allowed to add negative. Negative means electron. So 12, it needs to be reduced to 6 so that this will be balanced. So that means I need to add 6 electrons. You can always double check. Each electron is minus 1, 6 electron is minus 6. So now my charges are balanced on this half reaction. So make sure you first have this right, then you work on the second half reaction. In second half reaction, obviously we need to balance, let's go over this, balance elements other than hydrogen and oxygen. We have carbon. Now carbons are already balanced, so I don't need to worry about that. Then balance oxygen by adding H2O. I have 1 oxygen on the left hand side, 2 oxygen on the right side. So I'll have to have 1 oxygen on the left hand side. You cannot just add oxygen. You need to add H2O. Each H2O brings 1 oxygen, and that's why we add 1 H2O. So we balance now oxygen. There are 2 oxygens on both sides. And now we need to balance hydrogen by adding H+. Let's see how many hydrogens we have on each side. I have 2 hydrogen coming from here, 3, 4 hydrogen coming from these two, from CH3OH, and here I have 2 hydrogen. So I have 6 hydrogen on the left hand side, 2 hydrogen on the right hand side. So I must add 4 hydrogen on the right hand side. And you cannot just add hydrogen, it has to be H+. So it will be 4H+. So you're going to add 4H+, and that is going to take care of hydrogen. Let's now erase these, not to confuse you. Now let's find out what charges we have. On the left hand side we have both neutral, so there is no charge, 0 charge. 4H+, that's plus 4. So I have plus 4 on the right side, no charge or 0 charge on the left hand side. So I need to add electron, that's how I can balance charges. I cannot add electron on this side because that would make it negative, but I have a positive. So what I need to do is I need to add 4 electron because that would make minus 4 and it becomes neutral. Okay, so now we went through this and balanced each half reaction. Next step is step 6. You need to now balance both half reactions in such a way number of moles of electrons or number of electrons are same. Because one half reaction is giving up electron, other half reaction is absorbing electron. There cannot be mismatch, so it should be the same number. So balance electron for both reactions. What that means, must have same electron. Must have same electron. Because electron is being transferred from one half cell to the other, and it has to be the same number. So now between 4 and 6, I can think of 12, with the next closest number I can get, multiply this by 2. So 2 times this whole thing will give me 12 electrons. And here I need to multiply this whole thing by 3. And that's how you need to balance this reaction. So let's now multiply it. 12 electron, 28 H+, and then 2 Cr2O7, 2 minus, 4 Cr3 plus 14 H2O. So I multiplied this by 2 because I must have the same number of electrons, because these are coming from this cell. This is a half cell. That's going to transfer 12 electrons from this half cell to the other half cell. Now this is, you are multiplying by 3, so it will be 3 H2O plus 3 CH3OH, giving 3 HCO2H plus 12H plus 12. Make sure you double check my multiplication, but I'm just showing you how to do it right. So this is how going to do it, and that would give you same number of electrons. Now let's write down these two reactions, one underneath the other, so that we can better see it, what we're going to do next. So, and we're going to add them up. 3H2O, I'm just copying this 3CH3OH, CH3OH, giving 3HCO2H plus 12H plus 12 electron. This is like an algebra. I'm adding these two algebraic equations. What I have on the left side, if I have the same thing on the right side, we can cancel out or we can subtract. So 12 electron goes with this 12 electrons on the right side. Now, I have 12H plus on the right side, 28H plus on the left side. So let's bring it, subtract 12 from on each side. So it's a minus 12H plus. So now I can get rid of this. Now, let's now write down what we have at this point. I think we also can reduce the number of water. Subtract water from each side. I have 3 here, so I can subtract 3H2O on this side. So that will take care of 3H2O, and there's no H2O now. Let's see, no H2O on the left hand side. So now let's write down what is left. 2Cr2O7, 2 minus, plus 16H plus, because 28 minus 12, so 16H plus, plus 3CH3OH, giving 4Cr3 plus 11, this is 14 minus 3, 11H2O, and 3HCO2H. So this is my balanced reaction. Now, if I follow these rules strictly, this would automatically give me acidic balancing. So this is a balancing of reaction in acidic solution. So let's write down in parentheses acidic. Now you can follow the same rule for both basic as well as acidic solutions. Now let me tell you, if I want to change it to basic, the question is asking about balancing for basic solution. You can first get acidic and then change it in one step to a basic solution. Now this is how you can do it. So let's not confuse this. This is our acidic solution. In order to get the basic, you must have overall OH minus. If I see 16H plus, like in this case, we need to add 16 OH minus. So add 16 OH minus to change it to basic. 16 OH minus, and it has to be on both sides. 16 OH minus. Now how is it going to change? This 16H plus and 16 OH minus makes 16H2O. So it would be 2Cr2O7, 2 minus, plus 16H2O. I mean, this is, you should pay attention to. 16H2O plus 3CH3OH, giving 4Cr3 plus 11H2O plus 3HCO2H plus 16 OH minus. Now I can reduce that further, because now you see I have 16 H2O, I have 11 H2O. Subtract 11 H2O from each side. So 11 H2O. This term we get rid of. Now, so let's write down the basic balancing. So when you subtract 11, so this is going to be 2Cr2O7, 2 minus, plus 5H2O, plus 3CH3OH, OH, giving 4Cr3 plus 3 HCO2H plus 6OH, 16OH minus. This is the basic solution. Now you can see that overall I don't have any H plus, rather I have OH minus. So keep this in mind. In basic solution you'd have OH minus, in acidic you'd have H plus. Now in book they have two different rules, one for acidic, one for basic, but I follow same rule so that even if the question is on basic, I first get acidic solution and then at the end I add OH minus like this. So make sure you go over this problem and try to do it yourself. That's how you can understand better. Now something else I need to point out to you. This half of the cell is absorbing electron or receiving electron, and this half of the cell is giving up electrons. Giving up electron means oxidation. So this is undergoing oxidation reaction. Receiving electron means reduction. This is undergoing reduction reaction. So loss of electron is oxidation, gain of electron is reduction. We'll be coming back to this again when we do another problem. Then also we need to know how many electrons are being transferred here, because it's often used in problem solving. From one half cell to the other half cell, I say that there should be no mismatch. There's the 12 electrons being transferred. This is the 12 being transferred from one half cell to the other half cell. So number of electrons transferred equals to 12. So often we ask this kind of questions. That means you not only just balance it, you also find out what number do you have for electrons or for one of these compounds. So this was our practice problem number 5. Let's go over number 6. Now this question is on electrolysis and plating, metal plating. Now I can give you a simple example. Say if an iron rod, if you want to give a gold coating, you need to do electrolysis. So this is a very common thing. Usually coat one metal with another metal so that it gives you longer lifetime. It doesn't get rusted and it doesn't react with many chemicals. That's why sometimes different metal plating is done. Now let's go over a problem on this. I'm picking this from one of your homework that I have assigned. Say chromium 3 plus solution electrolyzed. Using 7.60 ampere of electricity. What is going to be the mass of chromium plated in 2 days? Now let me explain this to you, what's going on here. If this is your solution, there'll be two metals, or one metal and one non-metal. One has to be metal to plating another metal into it. Okay? And then you have a battery or source of electricity in here, there's two ends. So this is, let's call it battery. So if you have chromium 3 plus solution, now you can get chromium 3 plus solution from many compounds like chromium nitrate. If I have chromium nitrate, that will break down into chromium 3 plus in water solution. So you may have lots of these chromium 3 plus, and nitrate will be floating around. It's not going to take part in the reaction. Now, how does this reaction happen? You connect the battery in such a way that it pumps electron, it pushes electron along this side. So it has to be the anodic end of the battery. Anodic end of the battery is have a negative. So you know that one end of the battery has negative sign, another end has positive sign. So negative end pushes electron out along that direction. So it pushes electron out here, and this chromium 3 plus from the solution is going to grab 3 electrons. In terms of moles, 1 mole of chromium 3 plus would receive 3 moles of electron and become a chromium solid, and that's going to stick to this electrode. And that's how plating is done. Now what they're saying is they are going to, they're passing 7.60 ampere of electricity for 2 days. And let's do the problem and see what we get as mass of chromium. 7.60 ampere is same as coulomb per second. Let me write down here. 1 amp is 1 coulomb per second. Coulomb is the charge, unit of charge. So unit of charge per second is ampere. So I can write down as coulomb per second times 2 days, because you are passing that electricity for 2 days. And I can write down each day having 24 hours. And then each hour 3600 second. Now why we need to change it to second? Because this is second. So I cannot have days or hours in order to cancel out the second. So now you can see that we can take care of the unit. 2 day, so day would cancel out, hour would cancel out, second per second would cancel out, so I get coulomb at the end. Now what else we know? So what we can continue this in one step. 96,500 coulomb, that's in 1 mole of electron. So 1 mole of electron has, it's also called Faraday's number, Faraday's unit value. 1 mole of electron has 96,500 coulomb. In your data sheet, you should have that number. Then, from this reaction, we know that 3 moles of electron is going to deposit 1 mole of chromium. So that's important for us to know. So 3 moles of electron would deposit 1 mole of chromium, and we don't need to know the mass. I looked at periodic table. 1 mole chromium has 52.0 gram chromium. And if I do this calculation, this is what I got, 235.9, approximately you can write it down as 236 gram of chromium. So, if you pass electricity of 7.60 ampere for 2 days, you're going to plate out 236 gram of chromium around this metal. So that's the answer to this question. Now we're going to begin practice problem number 7. Now, this is on concentration cell. Concentration cell. It's a voltaic cell. That means I can get electricity purely because of the concentration difference between two half cell reactions. So this is one container, this is the other container with same solution. Let's assume that I have zinc in both places, zinc 2 plus. So that my concentration here is 1.00 times 10 to the negative 2 molar, and the other container has 1.80 molar of zinc. Now keep in mind, you get zinc 2 plus by adding a zinc compound, like zinc nitrate. Zinc nitrate would give you zinc 2 plus in water solution. So if I use 1 times 10 to the negative 2 molar zinc nitrate, that would break down into this much of zinc in water solution. Same is the case with 1.80 molar zinc solution. Now in a concentration cell, you would have everything else identical other than these concentrations. So I have a zinc as one of the electrodes here, and zinc as one of the electrodes here. So this is zinc, solid zinc. This is also solid zinc. Now, there should be, of course, salt bridge for neutrality. That would maintain the neutrality on each end. Otherwise, there would be no flow of electricity. So this is salt bridge, and when you connect them together, there will be flow of electricity because there is a variation in concentration. So what is given in this problem? These concentrations are given. So these are given. Let's write down this given. This is a concentration cell. Don't confuse this with other cell where you have a copper on one end and zinc on another end. That's not a concentration cell because electrodes are different. But here, electrodes are same, everything is same except the concentration of a chemical, same chemical on these both ends. Here we're going to find out a number of things. First we'd find out what is the cell voltage. What is the standard cell voltage? There's a difference between these two. Under standard state, what is this? And non-standard state, when the concentrations are not 1 molar, it's the non-standard state. What is the cell voltage? Then we'd also identify anode and cathode. Anode, which one is anode? Which one is cathode? In my lecture note, for your understanding or quick remembering, I use this, ANOX, anode oxidation. And I also mentioned cat red, cathode reduction. So this is anode oxidation. This is cathode reduction. Okay, and ox, cat red. Of course, cat is usually not red, but for this purposes, keep this in mind, cathode reduction. So we'll find out all these answers by going over this problem. Now let's first write down the chemical reaction. Before we do that, we need to understand, if we have this kind of variation, how long I can get electricity and when this electricity is going to stop. Remember, I said that this is going to give you voltage as long as there is a concentration difference. So as you draw electricity, what you're going to see is this concentration has to go up. Why? Eventually they will have to be same. This is smaller. This is a smaller quantity. In order to reach the other one, it has to go up. And this one, which is 1.80 now, has to go down. So this concentration should go down with time, this concentration has to go up with time. With that in mind, we can find out actually what reaction is going to happen on this end and what reaction is going to happen in this end. So let's write down this chemical reaction, zinc solid, giving zinc 2 plus 2 electron. Right now you're undecided. This zinc 2 plus would be in here or here. Which one is going to get rid of electron? This side or this side? Again, this should help you. Here the concentration must increase. Let's write down here. Concentration must increase. Because it's a smaller value. This is the larger value. Must decrease. Now that should help us to find out this reaction is going to happen whether left this side or this side. Here, as time goes on, if zinc is going to get rid of electron, zinc 2 plus concentration would go up. So in other words, this reaction, as this reaction happens, this concentration would go up. And that means we're talking about this concentration, the smaller value, times 10 to the negative 2 molar. Because this reaction would favor increasing of zinc 2 plus concentration. So now I can quickly write down the other one. Zinc 2 plus aqueous plus 2 electron would give zinc solid. And that's obviously with the higher concentration, 1.80 molar. Because this concentration go down. Now why it go down? It combines with electron becoming solid zinc. So that's going to get consumed. So just a few minutes ago we talked about oxidation, where electron is released or given up. Here zinc is giving up electron. So this is oxidation. So this is the oxidation step. And we have mentioned about anode oxidation. So that means this is anode. This is anodic reaction. Here electron is being added. That's a cathode. It's receiving electron. So loss of electron is oxidation. Gain of electron is reduction. So this is reduction process, and that happens at cathode. So now we can identify this as anodic reaction. This is anodic, this is cathodic reaction. Now let's add them up before I get the cell voltage. Zinc would cancel out. So I would have zinc 2 plus on the left side. Don't get confused between left side and right side. My aligning was not a bit off because this arrow should have been a little bit farther to the right. That way you would not be confused. 2 electron would cancel out. Then this would give me zinc 2 plus with here 1.80 molar. And this zinc 2 plus on the product side would be 1.00 times 10 to the negative 2 molar. Everything else cancels out. So this is what you get now. Now let's find out what is E0 cell, standard cell voltage. Giving E0 oxidation plus E0 reduction. Since it's the same metal, no matter whether you use the book value or any value that you can think of, this is going to be, one is going to be positive, the other one is going to be negative, but the same value is 0. It is the same electron. For same electron, oxidation reduction values are equal and opposite, so it will be 0. So standard cell voltage will be 0. That means standard means if I have everything in 1 molar concentration, and which we already understand, this is going to give you a voltage because of the difference in concentration. If my concentrations are exactly the same, 1 and 1, there'll be no voltage. And that's what it tells you, E0 cell. But voltage of this cell with concentration difference would not be 0. And that would be given by this expression I'm going to write down. E0 cell minus 0.0592 over n log of Q. We already know the n value. N value tells us how many moles of electrons are being transferred from one half cell to the other. This is 2, so that's n value. even though we cancel for overall reaction, but n equals to 2. So we should write down here, n equals to 2. So keep this in mind. In this kind of problems, n tells us how many moles of electrons or how many electrons are being transferred from one half cell to the other half cell. So let me now plug in all these numbers. This is 2, this is 0. We already know this is 0. So this is equals to minus 0.0592. This is a standard equation. You get it in the book and you find how we get this number. So 0.0592 divided by 2. This is n value for this particular one. Log of product minus product over reactant. Zinc 2 plus on the top. This is the product. 1.00 times 10 to the negative 2 divided by 1.80. Both are molarity and they're in this. Okay, now this is the value that I got. And make sure you double check my value. 0.0668. 0.0668 volt. So make sure you understand a problem like this. These are called concentration cells. And I would ask you to calculate voltage of this kind of concentration cell. My next question would be, I would say, a conceptual question. You would be able to answer them, this kind of questions, by knowing the definition and also understanding the problem itself. So practice problem number 8 on definition. I'll use the word definition. You need to know the following. Change in entropy of the system. What does that mean? Change in entropy for surroundings. Change in entropy of the universe. Similarly, change in heat content. System, just like before, system, surrounding, all those. Now let me explain to you, change in any of these quantity in system. System means, say you're doing an experiment in a beaker. Whatever is happening in the beaker, that's system. So if I have change in entropy means randomness. Can entropy go down or up when I'm doing an experiment in the beaker? Yes, it can happen both ways. As I mentioned before, if you're doing a reaction, if you find that number is decreasing, then obviously entropy is decreasing. If number is increasing, entropy will be increasing within the system. Now, what is change in entropy in the universe? Which would be system plus surroundings. If you add them together, then it becomes change in entropy of the universe. Now, second law of thermodynamics tells us that even though within the system, entropy can decrease or increase or remain the same, in the universe, it's always going to increase, according to second law of thermodynamics. That's not the case with delta H, which enthalpy change. So make sure you read those definitions rather carefully so that you can answer these questions. Now practice problem number 9. Again, this will be a conceptual question without doing any math. Again, this is on entropy. Predict sign of delta S. sign of delta S means delta S can be positive. Positive means final entropy of randomness is greater than initial. So that means final entropy is greater than initial entropy. This is, when it's minus, final is less than entropy initial. So this tells us increased entropy as you go from initial to final, decreased entropy. Some problems we can answer this question quite readily just by looking at what is happening in the reaction. Let me quickly go over this reaction. N2 gas plus 3H2 giving 2NH3 gas. Now the question is, what is happening in this case? Is delta S, as you go from left-hand side to the right-hand side, increasing or decreasing? How do we get that? These are all gases. It's not a heterogeneous. It's a homogeneous reaction. And I have 4 molecules, or in terms of mole, I have 4 moles of gases on the reactant side. But when they react, the number is decreased to 2. So when initially we had more molecules and finally we had fewer molecules, so obviously our randomness was greater to begin with. The randomness was decreased when it's number 2. Remember, you can better track down when number is decreased. So in this particular case, the final value, this is my final value of entropy, this is my initial value. So I can say, in this particular case, since final is smaller, so delta S will be given by final minus initial. A smaller value, so a smaller value and larger value at the beginning, so difference is going to be negative, so it's decreased. So just by saying that the number is decreased, entropy is decreased as you go from left-hand side to the right-hand side. Another example, calcium carbonate solid that breaks down into calcium oxide solid and carbon dioxide gas. Here, these are sitting at the bottom of a beaker. This is a gas. Now, gas has a lot more randomness than the solid. So as this reaction happens, of course you're getting more and more gases, so my final entropy will be greater than initial. So in this case, change in entropy will be positive, or entropy is going to be increased. Or we can write down delta S greater than 0. This is delta S less than 0. This is increased. So there will be a simple question like this in exam. So make sure you understand both. What plus means increased, minus means decreased. We are going to continue this review session, and we'll go over other types of problems, like question could be a maximum electrical work that you can get. The delta G, I should give you introduction at this time. Delta G not just tells us whether a reaction is going to be spontaneous or not, because if it's negative, it is spontaneous. Positive, it is non-spontaneous. It also tells us how much work you can get. So in electrochemical reaction, if by knowing the delta G value, I can tell how much electrical energy I can get from a particular reaction. So make sure you first understand that what information you can get, and then you can do a problem. So in the second part of this review session, I'm going to stop here and I'll continue on this in next segment.